Well, I set out to make what I thought was going to be a very short video to answer a question that a viewer had about Pentagrid converters. And it turned out to be another one of these swamp clearing exercises. I learned a lot about Pentagrid converters. I kind of thought I knew how most of what I needed to know about a Pentagrid converter, but I learned a lot. So I'm going to try to pass along some of that. But first, let me mention that a viewer asked about a suppressor grid in a 6SA7. And the short answer to that question is yes, there is a suppressor grid. We'll talk about that as we get a little further along. But this is not an ordinary tetrode or pentode tube. The reason it's called Pentagrid is because it has 5 grids. And of course a pentode only has 3 grids. So this is not a pentode, it's not a tetrode, which only has 2 grids. It's a special kind of tube. So let's get into exactly what it is and why it's built that way and what it's used for. So this is a schematic taken from an RCA tube manual of a typical All-American 5 AM radio. The design dates back to the 1930s actually, and they were still building these radios in the 50s, maybe even in the 60s. I'm not sure when they switched over completely from tubes to transistors. But the stage that we're interested in talking about is this Pentagrid converter. Now, for those of you who watched the Frugal Repairman series, you know that I worked on actually 2 different radios. I started on one and then switched to an RCA because the first one I had just had too many bad components. It had an open output transformer and trashed speaker, and just it wasn't worth restoring. Most of these All-American 5s, they have to be in reasonably good condition to be worth restoring because they sold them by the tens of millions. So let's look a little closer at the Pentagrid converter stage. I've kind of blown it up here so you can see a little better. Typically, the way these work is the antenna signal is coupled in usually through a little transformer. Sometimes it's by a loop antenna, but it's coupled into the middle grid of the Pentagrid converter. And we'll talk more about the structure in a little later. It's coupled into the middle grid. What most people, when they first come to this, at least when I first looked at this, don't realize is the bottom 3 elements, the cathode, the first grid, and the second grid, are actually being used as a triode in an oscillator configuration. And you may notice down here, I'll slide this up a little bit, you see a tapped coil, and the cathode current flows through a portion of that coil. The other end of that coil is coupled through a capacitor to the grid, and then the second grid is actually connected to B+. This point over here is actually just a positive 80 to 90 volts. So what happens is this circuit will oscillate at a frequency determined by this inductor and these capacitors. Now, one of these capacitors is variable, and basically the way this circuit works is the bottom half of the tube, or the bottom part of the tube, oscillates. You tune the oscillator mixes inside the tube with the signal coming in from the antenna and produces sum and difference frequencies. One of those frequencies, the difference, is called the intermediate frequency, and it gets coupled out through a transformer that picks off just the IF, normally around 455 kilohertz, and that gets carried through the rest of the receiver. But we're interested in this particular Pentagrid converter here, and so let's talk a little bit more about that circuit. So here is a kind of blown up view from I copied this from a tube manual, or actually I drew it while looking in a tube manual. And the filament, of course, heats the cathode. The cathode emits electrons. The electrons flow to the plate. But in the meantime, they also, because of the action of the circuit we just talked about, they also cause oscillation in the cathode and first grid that causes this electron stream to contain a frequency at the oscillator frequency. That is, at a frequency that can mix with the incoming signal. The incoming signal is normally coupled to pin 8. Then there are two more grids that usually are tied together. These are the screen grids. Now, notice it's the plate of this tube, or this section. This grid is being used as a plate, but it's also being used as a screen grid. So, what is the purpose then of this last grid? Well, that is the suppressor grid. And normally that is connected down to pin 6 here, or to the cathode. And it serves the same function as the suppressor grid in a pentode. In other words, if electrons either bounce off of or are secondarily emitted by the plate, those would tend to get back down into the stream of electrons. But this grounded suppressor grid, because it's much more negative than the plate, it tends to repel those electrons back to the plate. So we won't talk more about suppressor grids, but we will talk a bit more about the Pentagrid converter, because the question by the viewer reminded me of my days with my first electronics mentor, a fellow named Glenn. He happened to be our local postmaster. He was a good friend of my uncle's. My uncle used to buy me radios and at estate sales, bring them to me, and most of them didn't work, and I would fix them up and either give them or sell them at a very low price to other people who didn't have a radio. Anyway, we had a nice little thing going. Not very profitable, but a lot of fun, and did a lot of good, I think, in the community. So my uncle put me in touch with his friend Glenn, and I would go over to his house on Wednesday evenings, and he would teach me a little bit about electronics. Well, one of the things that the question reminded me of is those Wednesday nights with Glenn. So I thought I might show you something that he showed me when we were talking about the Pentagrid converter. He said, think about it not like one tube, but like two tubes, like this. Now, what we have here, if you see, is we have a circuit here which has an ordinary control grid, a screen grid, and a suppressor grid, and a plate, and a cathode. If you think of that third grid in the remember, we're actually talking about this third grid. If you think of that as both the cathode of the mixer and the plate of the oscillator, then this circuit makes a little more sense. At least it did to me. So normally you have the oscillator running away down here at the bottom. You have a stream of electrons flowing from the cathode to the plate, and in the middle you have this the signal. And so think of this as a cathode. Now, it doesn't actually emit the electrons. It actually forms what's called a space charge. But we won't get into all of that. The idea is that the electrons that actually are emitted by the cathode flow to this electrode. Let's just think of it as a conductor. And therefore, they are present here, where they can be attracted by this plate and flow on up through this second part. If you think of it this way, now what we're talking about is an oscillator and a mixer. Well, like most other things in life, everything is fine until it isn't. I was reading about Pentagrid converters, just refreshing my knowledge, things I had read in tube manuals going back, frankly, to the late 1950s, about pentagrid converters and superheterodynes and all of that. And so I went to the 1948 RCA tube manual, RC15, which you can download from tubebooks.org. And I was looking at the 6SA7 and the 6SA7 GT. Now the 6SA7 is a metal tube. Actually, it's there's one right there. But there also was a 6SA7 GT. Now the GT, the G means glass, and I think the T means tubular. Anyway, it doesn't have that Coke bottle shape of the real old tubes. It's kind of squat glass tube. So I was thinking, okay, so they put it in a glass envelope. Then I started looking at the pinouts, and I realized that there's something going on here that I never knew. The 6SA7, if you look at pin 1 of the GT, there's no connection. But pin 1 of the 6SA7, not the GT, the metal, is connected to grid 5 and S, which means shield. That actually means the metal can. Well, that set me off in a direction that I didn't think I was going to go in, of trying to figure out, well, in that case, how did they get the suppressor grid tied to the cathode if there's no connection to G5? Well, it turns out that if you look at the 6SA7 and the 6SA7 GT, the GT has the cathode and G5 tied together internally, whereas the 6SA7 just has the cathode connected, brought out. So, in a radio that uses a 6SA7, you have to connect pin 1 somewhere, and normally it gets connected to pin 6. So I started looking at radios of the period. And one of the radios I came across that used a GT rather than the 6SA7. Now, I saw a bunch of these. I don't want to say a million of these because it wasn't that many, but I saw hundreds of these, if not more. I used to work on these radios, and most of the radios of the time used either a 6SA7 or a 12SA7. Tube manual says they're the same except for the heater, and as far as I know they are. But I don't ever remember working on a radio with a 6SA7 GT. So I looked around till I found one. This is a Zenith 7R070. It's also chassis C6C06 for those of you that want to look it up. It's in Rider, Volume 18, American Radio History, museum.com, I think it is, if you want to find those. And I noticed, now, once again, this tube is drawn upside down. The cathode is at the top, well, the heater is at the very top, and then the cathode, and then the grids, and the plate is at the bottom. But disregard that for a moment. The point that I'm making is that you notice that pin 8, which is the so-called signal grid or antenna grid, is still the place where the signal is coupled. In this case, it's from a loop antenna, and is coupled up here into the center grid, called the signal grid. Once again, the bottom two grids are used in conjunction with the cathode to oscillate. But notice something funny. Pin 1 is grounded, but G5, pin 6 is tied to the cathode and to the suppressor grid, and if you follow that down, you see it goes through this inductor, which is part of the oscillator circuit. And so in this case, they don't have the suppressor grid tied to ground, but they do have it tied to the cathode because of the internal construction of the 6SA7 GT. Well, that led to a lot of other stuff that I won't get into, but what I did want to do is explain that why sometimes a viewer's question, I could have simply said, yes, it has a suppressor grid and gone on about my business, but being the, well, some people would say obsessive, I say curious person that I am, I decided to go back and look at what I thought I knew about Pentagrid converters, and I wound up learning some new things. I never knew there was a difference between the GT version and the metal version of the 6SA7s. I also learned a bit more about some of the construction of these tubes, and I'll just briefly mention, if you read the tube manual, you'll discover that they put a lot of attention into making sure, and in this case I'm going to go back to this picture. They put a lot of attention into making sure that the signal that you bring into the basically what is the signal grid does not modulate the cathode current. In other words, the tube is built so that these two parts work somewhat independently. The cathode current is almost exclusively determined by the oscillator section. And that's reasonable because remember, this signal that's coming in to the mixer part is normally in the order of 100 or 200 microvolts, maybe 500 microvolts if you live near a station. But the idea is not to let this section and this section interact too much. And it turns out there's a lot of literature on that. If you go back into the radio magazines of the day, I won't do that here. But if you're interested in a curious, or maybe I should say obsessive, look back at the past, go look at the history of these Pentagrid converter tubes. Fair amount of inventiveness went into them. Well, okay, let's kind of wrap that up. Let's take a quick look at a 6SA7 on the curve tracer, and then let's maybe summarize and move on to something that maybe is more interesting. Okay, now what we're looking at is the 6SA7 on the Tektronix 570 curve tracer, and I'll give you a brief what we're doing. Of course, is we're applying 6 volts to the heater. The cathode is grounded. We have right now pin 1, which is grid 5, connected to ground, which means connected to the cathode. We have grid B connected to pin 5. That is the oscillator grid. And then we are sweeping grid 2. Now, of course, because it's connected to grid 4, we're also sweeping grid 4. But so the plate sweep is on grid 2. So basically, we are operating this section as a triode, with this second grid actually being the plate. So what you see here is the plate current on the vertical axis and the plate voltage on the horizontal. Now I have the plate voltage set to 100 volts peak, and I'm doing that because in the radio that we looked at, the average All-American 5, usually there's between 90 or so volts, maybe 100 B plus on the Pentagrid converter. So what you're seeing here are steps of grid voltage. And so this is the characteristics of the 6SA7 if we use the bottom three elements as a triode vacuum tube. So taking one more look at these Pentagrid converters in a circuit, this, by the way, it happens to be the mixer or converter circuit from the RCA radio that I restored in the Frugal Repairman series. The Pentagrid converter in this case is a 12SA7, not a 6SA7, but as I say, the tube manuals claim them to be identical except for the heater. And notice the way that this one is arranged. This one has pin 1 tied to chassis, but the cathode is not tied to ground. So this is the top, need to show that, I guess. This is the top of the oscillator coil, and once again the secondary of the oscillator coil is coupled back to the first grid to form the oscillator, and the plate of the oscillator, which is actually the second grid, you'll notice is tied over here to 81 volts. The plate, on the other hand, is tied through the intermediate frequency transformer to that same 81 volts. But the plate current flows through the IF, the cathode current flows through this oscillator coil. So that gives you a little bit of an idea of the Pentagrid converter. I've frankly learned a lot in just researching and trying to refresh my memory about these things. I hope you learned a little something too. But in the meantime, the basic thing is have some fun, stay safe, come back for some more videos, and let's all have a nice day.